myself, Professor Joshi PM from ADSUL'S Technical Campus, Chas Ahmednagar. Today we discuss the EMF equation of transformer. Okay, so to understand the EMF equation of transformer, we have to derive here the EMF equation of transformer. So let's start our session. EMF equation of transformer. EMF equation of transformer. To derive the EMF equation of transformer, first of all we have to draw here a simple circuit diagram of transformer. There is simple circuit. We draw here simple circuit diagram of transformer. This is the core of transformer. After that, we have to draw here primary winding of transformer. Last lecture we briefly explained what is meant by primary winding, what is meant by secondary winding. So these are the magnetic fluxes travel from the primary winding to the secondary winding. So here current I1 passes from primary winding, which generates the magnetic flux which interact with the secondary winding. After that, EMF we induce in the secondary winding. This is the core. After that, these are the magnetic fluxes denoted by phi. These turns are N1, these turns are N2. EMF induced in primary is E1, EMF induced in secondary is E2. Okay, so let's first of all consider the applications. Let E1 equals to RMS value of induced EMF in primary. So that E2 is RMS value of induced EMF in secondary. N1 number of turns of primary winding. After that, N2 is a number of turns of secondary winding. After that, F is equals to frequency of alternating quantity in hertz. Okay, next phi is the flux in Weber. After that phi is the maximum flux in Weber. Maximum flux in Weber. Okay, then last is V is the supply voltage and I is primary current and I is secondary current. These are the abbreviations. We have to use these abbreviations in our EMF equation. So let's start the EMF equation. So after that we have to draw here a single graphical format of EMF versus of flux versus time. So we have to draw this. This is the flux and this is the time. But alternative we have to draw here one alternating quantity. This is a single alternating quantity. This time is called, this total time is called T. Okay, this is the total time T. Here half flux, here full flux, here phi m means maximum value of magnetic flux, and this is the time. But this time is 1/4 of time. That means what is the value of this time is T upon 4f. T upon 4f. This is the time of T upon 4f. This is the total time, and this is the maximum flux. So here we draw here maximum flux that can travel from 0 position to 360-degree position. Okay, now the flux increases from 0 to its maximum value. Okay, these are the flux waveform. Flux increases from its 0 value. Here is 0 value from its max value. This is the max value in 1/4 of the cycle. Okay, this is the 1/4 of the cycle. This is the half quadrant. This is the 1/4 of the cycle. Means fluxes travel from 0 to its max value in 1/4 of the cycle. This 1/4 is 1 upon 4f. This is 1/4 is 1 upon 4f. So the average rate of change of flux is then the average. I will draw this. So the average rate of average rate of what we have to draw here, the average rate of change of flux. Okay, what is the average rate of change of flux? Change of flux equals to average rate of change of flux equals to d phi equals to d phi means average rate of change of flux equals to phi m upon phi m upon t upon 4f. This is the average rate of change of flux, but we have to consider that it is 1. That means average rate of change of flux equals to phi m upon 1 upon 4f. If we rearrange this term, we will get phi m equals to 4f phi m. If we rearrange this term, we will get phi m equals to 4f phi m. This is the average rate of change of flux. If the flux varies, we know that we draw here the flux waveform is like a sinusoidal waveform. Okay, then the average induced EMF, what is the value of average induced EMF? The average induced EMF is the 4 phi equals to 4f d V5 equals to 4F5. Okay, then if you use the formula of form factor, we will get the average value is the 1.11 into RMS value. So if we rearrange this term, we will get the RMS value equals to 1.11 into average value, because we know that the formula for the form factor is equals to RMS value upon average value, and the value of form factor is 1.11. Therefore, RMS value is equals to 1.11 into average value, because of form factor equals to RMS value upon average value. Then if flux varies sinusoidally, then RMS value of induced EMF is obtained by multiplying the average value with form factor. Then RMS value equals to 1.11 into average value. Therefore, the RMS value of EMF, what will we get? Then RMS value of EMF induced equals to, what we will get? 1.11 into 4F5M. Okay, then if we multiply this term by this term, we will get 4.44F5M. Okay, this is the value of RMS value of EMF induced. What is this value? 4 into 44F5M. Okay, now we have to find out the RMS value of induced EMF in primary. Okay, what we have to find out? The RMS value of induced EMF in primary. Okay, then what will we get? RMS value of induced EMF in primary. We have to get induced EMF in primary. We have to multiply by primary number of turns, that is N1. Then what we will get? 4.44. What is the RMS value of induced EMF? 4.44 F5M into N1. Right? 4.44 F5M into N1. So we know that the abbreviation RMS value of induced EMF primary is E1. Then by putting E1, we will get 4.44 F5M N1. This is the value RMS value of induced EMF in primary. So similarly, we can get the RMS value of induced EMF in secondary. Then RMS value of induced EMF in secondary equals to, what we will get? 4.44 F5M into N2. So we know that the RMS value of induced EMF in secondary we can write as the abbreviation E2. Then what will be the final answer? E2 equals to 4.44 F phi m and 2. This is the RMS value of induced EMF in secondary winding. Okay, but in case of ideal transformer, the RMS value of induced EMF is equals to the supply voltage. That means in case of ideal transformer, E1 equals to V1, and E2 equals to V2 in case of the ideal transformer. Okay, in case of ideal transformer, E1 equals to V1, E2 equals to E2, but in practical transformer, average value or the RMS value of induced EMF in primary side E1 is 4.44 F phi m N1, and RMS value of induced EMF in secondary winding is E2 equals to 4.44 F phi m N2. Okay, I hope you can understand this derivation.